Mathematics Paper 1, Pure Mathematics 1, Wednesday, 7 October 2020. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make sure your methods are clear. Answers without working may not gain full credit. Question number 1. Find the first four terms in ascending powers of x of the binomial expansion of 1 plus 8x to the power half, giving each term in simplest form. Explain how you could use x equals to 1 over 32 in the expansion to find an approximation for square root of 5. There is no need to carry out the calculation. To do question 1a, we would use this binomial expansion formula. So where we will replace x with 8x and we will replace n with a half. So n is a half, so it would be 1 plus half times 8x plus n is a half and then bracket half minus 1 and then 8x all squared. And you have to be careful here because it is the 8 squared and the x squared as well. And you do the same, n bracket n minus 1. And then when you come to x cubed, it would be 8x cubed. So 8 cubed and then x cubed. When you put that in your calculator, you will get 1 plus 4x minus 8x squared plus 32x cubed. For question 1b, you substitute x equals to 1 over 32 and you would get 1 over 32 times 8 plus 1. That gives you 5 over 4 to the half. 5 to the power half is square root of 5 and square root of 4 is 2. So what you're going to do is when you substitute 1 over 32 in place of x, you'll get your answer, but you don't want the 2. So you would have to multiply the result by 2 because you only want to get square root of 5. So multiplying by 2 get rid of the 2 or cancels the 2. So that's your complete answer for questions 1a and 1b. Question number 2. By taking logarithms of both sides, solve the equation. 4p minus 1 equals to 5 to the power 210, giving the value of p to 1 decimal place. To do question number 2, we're going to use this power to the front law or the power law. Log of x to the k base a is equals to k log x to the base a. So the k comes in front. So what we want to do first is we put log in front. Log 4 to the power 3p minus 1 and log 5 to the 210. 3p minus 1 comes to the front and 210 comes to the front. Now it is times log 4. So we take the times log 4 to the right, it becomes divide by log 4. Now it is minus 1 on the left, we take it to the right, it becomes plus 1. So 3p is equals to 210 log 5 over log 4 plus 1. It's times 3p. We take the times 3 to the right, it becomes divide by 3. And you would put all of that in your calculator to get the answer. And when we put that to the calculator, we put 210 log 5 divided by log 4 plus 1 and the bracket divided by 3, you get 81.6008. And the answer to 1 decimal place is 81.6. So that's the complete answer for question number 2. Question number 3. Relative to a fixed origin, point A has position vector 2i plus 5j minus 6k. Point B has position vector 3i minus 3j minus 4k. And point C has position vector 2i minus 16j plus 4k. Find AB. Show that the quadrilateral OABC is a trapezium, giving reasons for your answer. For question 3A, we're going to use this formula. AB is equals to OB minus OA, where OA and OB are the position vectors of A and B respectively. It's very important. It is OB minus OA, the second letter minus the first. So when we do that, AB is 3I minus 3J minus 4K minus 2I plus 5J minus 6K. So 3I minus 2I, it gives you I. Minus 3J minus 5J gives you minus 8J. And minus 4 minus 6, it gives you plus 2. Minus 4 minus 6. This becomes a plus. It becomes 6 minus 4. It gives you 2K. Question 3B. I've written vector A as a column vector, B as column, C as column, and AB as column. And you will notice that if you multiply 2 times AB is 1 minus 8, 2. So 2 times 1 is 2. 2 times minus 8 is minus 16. 2 times 2 is 4. So that means OC is the same as 2 times AB. If you look there, you have OC is the same as 2 times AB. That means OC and AB are parallel. OC is parallel to AB. So OABC is a trapezium. A trapezium has one pair of parallel sides. So I've got here a diagram for trapezium. So that means AB is parallel to OC. So a trapezium, one pair of opposite sides are parallel. So it is important to note that there are two definitions for a trapezium. One stating that it is a shape with one pair of parallel sides, the other with only one pair of parallel sides. So any calculations with OA and BC in this question may be ignored, even if it is correct. You just want to show that two sides are parallel. So that's your complete answer for questions 3A and 3B. Question number 4. The function f is defined by f of x is equal to 3x minus 7 over x minus 2. Find f inverse of 7 and show that f of x is equal to ax plus b over x minus 3, where a and b are integers to be found. So to do question 4a, the first thing we need to do is to find f inverse of x and then substitute in x equals to 7. So we would change f of x and call it y. So that means y equals to 3x minus 7 over x minus 2. The x which I've put in yellow, we're going to make that x the subject. So to make x the subject, we'll cross multiply. It becomes y times x minus 2 is equals to 3x minus 7. Now we would expand. Y times x is yx. Y times minus 2 is minus 2y. After that, we will put all the x to the left and all the others to the right. So minus 3 will come to the left, plus 3 will come to 3x will come to the left, it will be minus 3x. And minus 2y will go to the right, it will become plus 2y. Now we factorize, there's x there and there's x there. So if x comes out of the bracket, is y minus 3 equals to minus 7 plus 2y. After that, we divide by y minus 3. So x now is minus 7 plus 2y divided by y minus 3. Finally, we can swap x and y. So you get the new expression. And that y now is your f inverse of x. So to get f inverse of 7, you replace x with 7. So wherever you see x, you put 7. So it becomes minus 7 plus 2 times 7 over 7 minus 3. So f inverse of 7, it gives you 7 over 4. For question 4b, we want to find f of x. So we will substitute f of x to replace x in f of x. So if you follow that blue line I've put, so that's f of x, that will replace the x, and that will replace the f of x, will replace the x, and it will replace the x in f of x. So we would have the expression 3 bracket 3x minus 7 over 2 minus 7 over 1 all over 3x minus 7 over x minus 2 minus 2 over 1. So we have numerator and denominator. Now we're going to do this type of question. Let's work with the numerator first, simplify it, and then after we simplify the denominator, and then after we put them together. So to do the numerator, we would multiply, cross multiply, follow those yellow lines. It will be 3 times 3x minus 7 times 1 is equals to minus 7 times x minus 2. So 3 times x will give you 9x. 3 times 3x will give you 9x. 3 times minus 7 will give you 21. Minus 7 times x will give you minus 7x. And minus 7 times minus 2 will give you 14. So 9x minus 7x gives you 2x. Minus 14, minus 21 plus 14, it gives you minus 7 over x minus 2. Now we're going to deal with the denominator. So for the denominator, we'll have 3x minus 7 times 1 minus x minus 2 times 2. So we remove the brackets. 3x minus 7 minus 2 times x is minus 2x. Minus 2 times minus 2, it gives you plus 4. 3x minus 2x, it gives you x. Minus 7 plus 4, it gives you minus 3. Now we'll put the numerator and the denominator together. So the numerator divided by the denominator. We change the divide to a times and flip the second fraction. So we'll have x minus 2 in the denominator and x minus 2 in the numerator would cancel. So you're left with 2x minus 7 divided by x minus 3. And that means your A is the 2 and your B is the minus 7. So that's your complete answer for 4A, 4B, and the final part of 4B. Question number 5. A car has 6 forward gears. The fastest speed of the car in first gear is 28 kilometers per hour. In sixth gear is 115 kilometers per hour. Given that the fastest speed of the car in successive gears is modeled by an arithmetic sequence, find the fastest speed of the car in third gear. Given that the fastest speed of the car in successive gears is modeled by a geometric sequence, find the fastest speed of the car in fifth gear. So what we do is we want to use an arithmetic sequence. And I've got at the top there the formula for the arithmetic sequence. A is the first term and D is the difference. So we got the first, second, third, fourth, fifth, and sixth gear. First is 28 and the sixth is 115. Now, if we count the difference, 1, 2, 3, 4, 5. So we find 115 minus 28, that gives us 87. 87 divided by 5. The 5 comes from 1, 2, 3, 4, 5. And that gives us 17.4. That's the difference, 17.4 each. Now we use this formula for the n term, dn plus a minus d. The formula is the same like this one. I've just rearranged it slightly differently. A is the first term, which is 28. So 28 is the first term. The difference is 17. So using that formula for the n term, the difference is 17, and there's an n term, plus A is 28 and D is 17. So that will give us 17n plus 28 minus 17.4 gives you 10.6. Now for the third year, n is 3. So we substitute n is 3 in there. So 17.4 times 3 plus 10.6. That gives us 62.8 kilometers per hour. And that is for the third year. For part B, 5B, the n term is given by that formula at the top, a arrow to the n minus 1. First term, n is 1, so a arrow to the 1 minus 1. 1 minus 1 is 0. So arrow to the power 0 is 1. So it's a. So the first term is 28 kilometers per hour. The sixth term is a arrow to the 6 minus 1. 6 minus 1 is 5. So the sixth term is a arrow to the 5. But we know a is equal to 28. So a is equal to 28. So you substitute 28. So the sixth term is equal to 28 times arrow to the 5. But the sixth term is 115. So 115 is equals to 28 times arrow to the 5. So arrow to the 5 is 115 divided by 28. The opposite of arrow to the 5 is the fifth root. So we want to find the fifth root of 115 over 28. Now, we want to find the fifth term, a arrow to the 5 minus 1. 5 minus 1, it gives you 4. So the fifth term is a arrow to the 4. We need to sub in for a, and we need to sub in for r. So since a is 28, and r is the fifth root of 115 over 28, and you put that in your calculator, and that should give you the answer of 86.694. So in the Casio calculator, you will put 28, you will put the bracket, and then you will put the fifth root of 115 divided by 28 to the power 4, and that will give you 86.694. And to round it to one decimal place, you put a line after the 6, and the 9 is bigger than 5. You add it to 6, it becomes 86.7. So that's your complete answer for question 5A, 62.8 kilometers per hour, and your answer for question 5B, 86.7 kilometers per hour. Question number 6. Express sine 2x plus 2 cos x in the form r sine x plus alpha, where r and alpha are constants. R is greater than 0, and 0 is less than alpha less than pi over 2. Give the exact value of r and give the value of alpha in radians to 3 decimal places. The temperature, theta degrees Celsius, inside a room on a given day is modeled by the equation, where T is the number of hours after midnight. Okay, we're going to do part A first. And for 6A, we're going to use the formula below. So A sine x plus or minus b cos x can be expressed in the form r sine x plus or minus alpha. So we're going to use this first one to help us to do question 6. So for question 6A, we will write r sine x plus alpha as r sine x cos alpha plus r cos x sine alpha. Now, when we compare 1 sine x plus 2 cos x, we compare it with r sine x cos alpha and r cos x sine alpha. So the 1 is similar to r cos alpha because it's 1, in front of it is sine x. R cos alpha, in front of it is sine x. So that means 1 is equal to r cos alpha. When we compare the 2, is equivalent to r sine alpha because in front of 2 is cos x, in front of arrow sine alpha is cos x. So cos x, cos x. So what is in front? 2 is equals to arrow sine alpha. So 1 is arrow cos alpha, 2 arrow sine alpha equals to 2. Now to solve this simultaneous equation, we can square them and then add them. So arrow squared cos squared alpha equals to 1 squared. Arrow squared sine squared alpha equals to 2 squared. When you add them, 1 squared plus 2 squared will give you 5. Arrow squared cos squared alpha plus arrow squared sine squared alpha. You can factorize arrow squared out, and then you get cos squared alpha plus sine squared alpha. Cos squared alpha plus sine squared alpha is identical to 1. It's one of the identities. So you end up with arrow squared is equals to 5, and arrow is square root of 5. Another way to get arrow quickly is 1 squared plus 2 squared square root. That gives you 5. Watch that. 1 squared plus 2 squared and square root of that will give you root 5. Equation 2 divided by 1. Arrow sine alpha divided by arrow cos alpha is equals to 2 divided by 1, which is 2. It becomes tan alpha. Alpha will be inverse tangent of 2, and make sure your calculator is in radians, and you get 1.1071487, and alpha would be 1.107 when you round it to 3 decimal places. So what they're saying is sine x plus 2 cos x is root 5 sine x plus 1.107. And that's the graph there. If you plot y equals to sine x plus 2 cos x, that's what the graph looks like. And if you also plot the answer, you'll get the graph would meet. They'll be the same graph because they are the same. So when you get your answer, sine x plus 2 cos x is equals to square root of 5 sine x plus 1.107. To show that the two graphs are the same, and that's something you can do to check your answer in an exam, you will plot sine x plus 2 cos x, and that will be this red graph. When you put that in your calculator, is there y2, it will be this red graph you see there. And when you put the right hand side, square root of 5 sine x plus 1.105, it will give you this blue graph. And that's the one for the blue graph there. So you notice that you can take the red graph and put on top of the blue one, they will fit together. The fact that they can fit together, it shows that the left side is equals to the right side. That's how you can check your work during the exam. Plot the two graphs, the left side and the right side and left side. And if they fit together, your answers are correct. For question 6b, the temperature theta degrees inside a room on a given day is modeled by the equation theta is equal to 5 plus sine pi t over 12 minus 3 plus 2 cos pi t over 12 minus 3, where t is the number of hours after midnight. Using the equation of the model and your answer to part A, deduce the maximum temperature of the room during this day. So what you want to do now is take what you have done in part A, and x is pi t over 12 minus 3. So replace x with pi t over 12 minus 3. And then what you want to do is to replace all of that with square root of sine pi t over 12 minus 3. So you are using the function in yellow, which replaces the one in red is being replaced by the one in yellow. I repeat, the one in red, I've circled in red, is being replaced by this one in yellow. So when you replace it, the square root of 5 stays the same. You change the x you change it to pi t over 12, because pi t over 12 comes from that first one. And then when the temperature is maximum, the maximum is when sine of all of these I've put in circle is equals to 1. Everything, when the sine is that equals to 1, it is a maximum. And if all of that is equals to 1, you're left with 5 plus root 5 degrees Celsius, which is 7.24 degrees Celsius. Because a sine graph looks like that, and the maximum is at 1. So that gives you the answer 7.24 degrees Celsius. For question 6c, find the time of the day when the maximum temperature occurs, giving your answer to the nearest minute. The maximum occurs when that value is equals to 90 degrees, pi over 2. So pi t over 12 minus 3 plus 1.101 equals to pi over 2. Because if you look at the sine graph, it goes like that. So at 90 degrees, pi over 2 is when you get that maximum value of 1. So you want to solve this to find what t is. You want to make t the subject. So t would be pi over 2 minus 3 goes to the right, it becomes plus 3. Plus 1.107 goes to the right, it becomes minus 1.107. Divide by 12 goes to the right, it becomes times 12. And times pi goes to the right, it becomes divide by pi. And when you put all of that in your calculator, you can see I've done it on the right hand side there. You will get 13.23072737. Now we want to change 0.23072737 to minutes. So we times that by 60. When you multiply by 60, it gives you 13.84, which is roughly 14 minutes, approximately 14 minutes. So the time would be 13:14. That means 1:14. So t is a number of hours after midnight. So 13:14 or 1:14 p.m. or 13 hours and 14 minutes after midnight. And you can also use your calculator to check if it is correct. If you plot that function sine pi x over 12 plus 1.107 minus 3, you will get that curve there. And make sure you use this view window to see the whole graph. And you will see that it occurs at 13.20230, the maximum there. When you use GSolve and find the maximum, it will occur at x equals to 13.23. So that's another way to use the calculator to check if your answer is correct. Question number 7. Figure 1 shows a sketch of a curve C with equation y equals to f of x and a straight line L. The curve C meets L at the point minus 213 and 025 as shown. The shaded region R is bounded by C and L as shown in figure 1. Given that f of x is a quadratic function in x, minus 213 is the minimum turning point of y equals to f of x. Use inequalities to define R. To solve this question, we're going to use this formula. The gradient of a line joining the point with coordinates x1, y1 and x2, y2 is given by that formula. We're going to use that. And we're also going to use this formula, y minus y1 is equals to m bracket x minus x1. And we're also going to use this one, f of x is equals to a bracket x plus p all squared plus q. And the turning point is minus p q. So very important, the ones I've circled, we're going to use them to do this question. And when you complete the square, this p bracket x plus q all squared plus r is the same like this. And this just shows you the way to complete the square. So we need all these ideas to do this question. So what we want to do first is to establish x1, y1, x2, y2. Now using that formula, the gradient m is 25 minus 13 divided by 0 minus minus 2. That will give us 6 for the gradient. Now we want to write the equation of the line using y minus y1 equals to m bracket x minus x1. So it becomes y minus 25 is equal to 6 bracket x minus 0. So you remove the bracket, 25 goes to the right hand side, it becomes plus 25. So the equation of the line is y equals to 6x plus 25. Now, what we want to do now, we use this equation to complete the square. So we have y equals to a bracket x plus 2 all squared plus 13. Because 2 and 13, minus 2 and 13. So y is 25 and x is 0. So you substitute that in 0 plus 2 squared plus 13 and 25 on the left hand side. So 25 minus 13, we want to make a the subject. Take plus 13 to the left, it becomes 25 minus 13 and divide by 4 is a. So that gives us a to be 3. So a is 3 bracket x plus 2 all squared plus 13. We can expand this. X plus 2 squared is the same as x plus 2 times x plus 2. When you expand that, it gives you x squared plus 4x plus 4. Now you remove the bracket. 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times 4 is 12. 12 plus the 13, it gives you 25. So you can write equation of the curve of C is y equals to 3 bracket x plus 2 squared plus 13, or y equals to 3x squared plus 12x plus 25. So when we want to define the shaded area, we want the part which is above the curve, and we want the part which is below the line. Remember that it is above the curve and it is below the line. So region arrow is defined by 3 bracket x plus 2 squared plus 13 less than y less than 6x plus 12. So that is, the less than means is below the line. So it's between the curve and the line. And or you can do the inequalities separately. You don't have to put them together. You can do it separately. Y is less than 6x plus 25. That one I showed you, which is below the line. And y is greater than 3 bracket x plus 2 all squared plus 13, the one which is above that curve. Or you can give it in set notation, x, y, such that y is greater than, bigger than the curve, above the curve, 3 bracket x plus 2 squared plus 13. Intersection, that's what it means, intersection, where they meet, intersection, the xy, where the y less than 6x plus 25, the ones that are below the line. So what they're saying to you is that what is above the curve intersect what is below the line. Let me put this again so you can see clearly. What is above the curve and I'll do it again so you can see there. What is above the curve and what is below the line. So that's what you want to do. Question number 8. A new smartphone was released by a company. The company monitored the total number of phones sold N at time T days after the phone was released. The company observed that during this time, the rate of increase of N was proportional to N. Use this information to write a suitable equation for N in terms of T. So we can have N is equals to A e to the kt, where A and K are positive constants. Or you can write it as N is equals to e to the kt plus c. Or you can write as ln N is equals to kt plus c. Or some people can do it like N is equals to a k to the t. And you can note dn over dt is equals to a k to the t times ln k, which is ln k times n. And dn over dt is proportional to n. And for this one, you can also expand this to write it as n is equals to e to the kt times e to the c. So if you have that as e to the kt times e to the c, and you can call that e to the c a, so that would be a e to the kt, which is the same like this one. So that's just different ways of writing the same answers. Question number 9. Figure 2 shows a sketch of the curve C with equation y equals to f of x, where f of x is 4 bracket x squared minus 2 times e to the minus 2x. Show that f dash of x is equals to 8 bracket 2 plus x minus x squared bracket e to the minus 2x. Okay, we want to differentiate. So to differentiate, we're going to use the product rule. Y equals to u times v. And it says dy over dx is equals to v times du over dx plus u times dv over dx. So since our y is equals to 4 bracket x squared minus 2 times e to the minus 2x. So we can choose u. Let u be equals to 4 bracket x squared minus 2. We remove the bracket. 4 times x squared is 4x squared. And 4 times minus 2 is minus 8. And du over dx, differentiate 4x squared, you get 8x. And you differentiate minus 8, you get 0. And then we have v is equals to e to the minus 2x. Differentiate e to the minus 2x. First of all, differentiate minus 2x, you get minus 2. So minus 2 comes in front times e to the minus 2x because it stays the same. Now, you want to write dy over dx. Using the formula, you want to put e to the minus 2x, which is your v, and then du over dx, which is 8x, plus u, which is 4x squared minus 8, times dv over dx, which is minus 2 e to the minus 2x. So all we are substituting is for v, for du over dx, for u, and for dv over dx. Now you start to simplify, to change it to look like what they ask you to. So we have 8x e to the minus 2x minus, we can remove this bracket, minus 2 times 4 is minus 8x squared e to the minus 2x, and minus 2 times 8 is 16 e to the minus 2x. Now you notice there's 8 there, there's 8 there, and 16 is 2 times 8. So 8 will come out of the bracket. Now you're left with x. There's e to the minus 2x, e to the minus 2x, e to the minus 2x. That comes out of the bracket. We put it in front of it, or you can put it behind. But we just want to do it the same like what they want us in the question. That's why. So you end up with, and then you swap, the 2 can come at the front, and this one goes in the middle. So you have f dash of x is 8 bracket 2 plus x minus x squared times e to the minus 2x. And then q e d. It's Latin for which means as required to show. Question 9b says, hence, find in simplest form the exact coordinates of the stationary points of C. So we have f dash of x is equals to 0, or dy over dx is equals to 0. So we put 8 bracket 2 plus x minus x squared times e to the minus 2x equals to 0. Now, either the 8 is equals to 0, e to the minus 2x is equals to 0, or 2 plus x minus x squared equals to 0. If you put that in your calculator, where the number in front of x squared is minus 1, the number in front of x is 1, and the number without x is 2, your calculator will give you the 2 answers, 2 and minus 1. So the values for x are 2 and minus 1. So you can substitute minus 1. So to find the value for y, you use the original function that they gave you in the beginning to find the values for y. So we'll substitute -1 first. That gives you 4 times my bracket -1 squared minus 2 bracket close times e to the -2 times -1. Put that in your calculator, you get -4e squared. So it is xy is -1 comma -4e squared, and it says exact value. That's why there's no decimal. It's no decimal because we want the exact value. And then we do the same and we substitute 2. So in place of x, we put 2. So 4 bracket 2 squared minus 2 bracket close e to the -2 times 2. Put all of that in your calculator. It will simplify to give you 8e to the -4. So leave the e to the -2 times 2 and don't put that in the calculator because you want to have 8e to the -4. So your xy would be, when x is 2, y is 8e to the -4. So your stationary points, there's 2 of them, -1 and -4e squared, and 2 and 8e to the -4. Always give the x and the y, x and the y. Question 9c. Find I the range of G and the range of H. So for question 9c, g of x is equals to 2 times f of x. Find I the range of g. Now, if we have 2 times f of x, we multiply 2 times f of x. So it will be 2 times 4, that will give us 8. So in front now it will be 8 and the rest stays the same. So whatever we had, it will be 2 times the minimum value of y. Before, we had the minimum point as -1 -4e squared. So what is going down is the y value. You multiply the y value by 2. And when you multiply 2 times -4e squared, it becomes -8e squared. So remember, 2 times the minimum value of y, because it is 2f of x. There's the 2 in front. So the -1 stays the same. You multiply that, so it'll be -8e squared. So the range from -8e squared to infinity, a very large, that's what infinity means. So you start from -8e squared to infinity. Or you can write it as g of x is bigger than or equals to -8e squared. That means anything bigger than -8e squared going upwards. For question 9c, h of x is 2 times f of x minus 3. And you notice x is bigger than or equals to 0. So we multiply by 2 and we minus 3. And remember, x must be bigger than or equal to 0. So the range of h is what we want to find. So h of x, let's put in 0. 2 times f of 0. When we put 0, 2 times f of 0 minus 3 will give us -19. And that will give us the lower bound when we put in 0. So the lower bound is -19. From before, the maximum point was 8e to the -4. So h of x is 2f of x minus 3. So 2 times that maximum point minus 3. That will give us 16e to the -4 minus 3. So 2 times the maximum point minus 3. So the upper bound is 16e to the -4 minus 3. So your range goes from the lower bound to the upper bound. -19, 16e to the -4 minus 3. You can write it like this: -19 less than or equals to y less than or equals to 16e to the -4 minus 3. So for 9c, if you put it in a calculator, if you put that in your graphics calculator, and you use this on the view window, it will show this graph to you where you have when x is 2, you get this point which is equivalent to that. If you put this in your calculator, 8e to the minus 4 is 0.146, which is the same there when x is 2. So you can use your calculator to check it if it's correct. Also, these are other ways. Minus 8 times e squared is minus 59.112. So when x is minus 1, you get minus 59.112, which is that. And that is how you put the view window to see it clearly. And these are the graphs which are put in the Casio calculator. So this number there matches with that, and that is when x is minus 1. So these are more graphs to show, make it clearer. That will be on the view window, the scale, and then that's the functions you put in the graph. And when you get 0 minus 19, that's the minimum point where you start. And then that's the maximum point. So that's minimum, maximum, or what you might say lower bound, upper bound. So that's this range. That gives you a visual understanding. I hope that helps. If you like this video, please make sure you subscribe. I try and make the video such that it would inspire students to want to do maths, and I hope you like this. Question number 10. Use the substitution x equals to u squared plus 1 to show that the integral of 3 divided by x minus 1, 3 plus 2 root x minus 1, can be written as integral of 6 over u brackets 3 plus 2u, where p and q are positive constants to be found. So to use the substitution, we can write u equals to x equals to u squared plus 1. So dx over du, when you differentiate u squared, you get 2u. 2 comes in front, and you subtract 1 from 2. And you differentiate plus 1, you get 0. And we rearrange it to make dx the subject. So dx is equals to 2u du. We'll take the du to the right-hand side. It's 2u times du. Now we change the limits. We had x equals to u squared plus 1. So when x is 5, we would have u squared plus 1. So u squared is you minus 1 from 5, you get 4. And u will be square root of 4, which will give you 2. And when x is 10, we need to find u squared. So 10 minus 1 gives you 9, and square root of 9 is 3. So p is 2 and q is 3. So now we can replace x minus 1 and replace dx. So we replace dx with 2u du. That's what we replace dx with. We replace x with u squared plus 1. So we replace x with u squared plus 1. And the limits are from 2 to 3 because we've changed it, not 5 to 10. Now, what you want to see to do is 1 minus 1 is 0. So you end up with u squared. 1 minus 1 there is 0. And square root of u squared is u. And we have the 2 there. And we have the 3. 3 times 2 is 6. One of the u at the top will cancel one of the u at the bottom. So you're left with integral from 2 to 3, 6 du over u bracket 3 plus u. And that's what you were asked to show. Hence, using algebraic notation, show that the integral is equals to ln a, where a is a rational constant to be found. So for 10b, what we want to do is we want to change that expression into partial fraction. You change the 1 into 2, and then after that it will be easier to work with them. So you can multiply the numerator and the denominator. You multiply by this same u bracket 3 plus 2u. You come here, you multiply u bracket 3 plus 2u times this one times a, and u bracket 3 plus 2u times b. So this would cross out with the first one, so you're left with 6. The u would cross out, so you're left with a brackets 3 plus 2u, and 3 plus 2u, 3 plus 2u will cross out, you're left with b and u. Now you can substitute u to be minus 3 over 2. How did I get minus 3 over 2? I look for a number that will make this part 0. What do you multiply by 2 and add 3 to get 0? So you multiply by minus 3 over 2. It'll give you minus 3. These two will cancel, you get minus 3. Minus 3 plus 3 is 0. So it gives a to be 0. And that multiplied by b, minus 3 over 2 times b. So b would be 6 divided by minus 3 over 2. So b is minus 4. And we can put u to be 0. That will cross out, b times 0 will be 0. 2 times 0 will be 0. 3 times a would be 3a. So 6 is equal to 3a, so a would be 2. So now you can write, now the one expression has become 2. So it's 2 over u minus 4 over 3 plus u. Now we can integrate from 2 to 3. When you integrate 2 over u, you get 2 ln u. It's the same like saying integrating 2 times 1 over u. Integral of 1 over u is ln u. When you integrate 4 over 3 plus 2u, you differentiate 3, you get 0. You differentiate 2u, you get 2. So you would have to divide by that 2. So it would be 4 ln 3 plus 2u, and then you divide by the 2 to compensate for that. So now you have 2 ln u minus 2 ln 3 plus u from 2 to 3. We need to substitute in 3 and substitute in 2. So what you would do now is 3 will go in there and in there. So you got 3 goes in there. And 2 will go in there and 2 will go there. Substitute 3 and 2 and you simplify. So 2 ln 3 minus 2 ln 3 plus 2 times 3. So you will get 2 ln 3 minus 2 ln 9 minus bracket 2 ln 2 minus 2 ln 7. These 2 can come to the front, power to the front, it becomes 3 squared. So ln 3 squared is the same as ln 9. Ln 9 minus 2 ln 9 is like saying 1 apple minus 2 apples. It will be minus 1 ln 9. And for this side, you can factorize 2 out. There's 2 there and 2 there. That 2 can come out. So you end up with ln 2 minus ln 7. When you subtract, you divide. So it becomes 2 ln 2 over 7. So the minus 1 can come to the power to the front. So minus 1 to the front becomes 9 to the minus 1. And the 2 can go in front. It becomes ln 2 over 7 squared. When you minus them, you divide. So it's ln 1 over 9 divided by 4 over 49. And when you do that, 1 over 9 divided by 4 over 49, you change it to a times. 1 over 9 times 49 over 4. And that will give you ln 49 over 36. So A is that value there, 49 over 36. This is another way to simplify it. The 2 comes to the front, power to the front there, it becomes 3 squared. The 2 comes to the 9, it becomes 9 squared. The 2 comes to the front there, it becomes 2 squared. And the 2 comes to the front there, it becomes 7 squared. So this 3 squared is 9, this 9 squared is 81. And when you subtract them, you divide them. So it's 9 divided by 81. And 2 squared is 4, 7 squared is 49. When you subtract them, you divide. So it's ln 4 divided by 49. And when you subtract here, you also divide. So it's ln 9 over 81 divided by 4 over 49, which you change to a times, and you'll get the same answer. So I think this method, this second method, is easier to simplify. So you can use it instead. Question number 11. Circle C1 has equation x squared plus y squared equals to 100. And circle C2 has equation x minus 15 all squared plus y squared equals to 40. The circles meet at points A and B as shown in figure 3. Show that angle AOB is equals to 0.635 radians to 3 significant figures where O is the origin. To do this question, it's very important to really understand the diagram. So if you look at this diagram, we want to find the angle which is shaded in yellow. So we can use this small triangle, which I have drawn in red, to find its small angle and then double it. That's the plan. Use the small triangle, right angle triangle, to find the angle and then double it to get the answer. So we would need to find the radius of the big circle. And from there, we can use x squared plus y squared equals to 100. So 100 is the radius squared. So that means the radius is 10. And the next thing we want to do is to find what the distance x is, the one I'm highlighting in red, that distance x. So we have the first circle, x squared plus y squared equals to 100. So we'll rearrange it to make y squared the subject. So y squared is 100. Take the x squared to the right hand side. So y squared is 100 minus x squared. Now we substitute that y squared to replace y in the second equation of the circle. So you got x minus 15 all squared plus, instead of y squared, we put 100 minus x squared equals to 40. We need to solve this for x. We expand x minus 15 squared. That will give us x squared minus 15x minus 15x plus 225 plus the 100 minus x squared equals to 40. The x squared minus the x squared gives us 0. X will cross out. Minus 15 minus 15 will give us minus 30. And then 225 plus 100 will give us 325. So we take the 325 to the right hand side, it becomes minus 325. So it becomes 40 minus 325. It's times minus 30. You take the times minus 30 to the right, it becomes divided by minus 30. So that will give us x to be 9.5. So x there is 9.5. That's the distance from the center to that point there. So that distance is 9.5. That's very, very important distance. Now to find the angle, we can use cosine of alpha. Cosine of alpha is adjacent over hypotenuse. The adjacent is the 9.5. The hypotenuse is the 10. Because that triangle is a right angle triangle. So the angle alpha is inverse cosine of 9.5 over 10, which is 0.451. Put your calculator in radians. Very important, your calculator should be in radians. So the angle AOB, the yellow angle, is 2 times that answer you got, 2 times the arc cosine of 9.5 over 10, which will give you 0.635 radians to 3 significant figures. The region shown shaded in figure 3 is bounded by C1 and C2. Find the perimeter of the shaded region, giving your answer to 1 decimal place. So perimeter is the total distance around the first circle, get to the point B and around the next one. The shaded I've put like that. So we want to use the formula S equals to arrow theta. For the first circle, arrow is 10. And what is the angle? The angle is this one behind there, because we are going around at the back like that. So it's 360 minus what we had before. Instead of 360, we're using 2 pi because it's in radians. So this the arc is S, and that's the arc there, which is S, is equals to the radius, which is 10, times this angle, which is 360, 2 pi minus alpha, this angle there, which is 0.635, and that gives you 56.48. Circle C2 has equation x minus 15 squared plus y squared equals to 40. The center of C2 is 15, 0. The radius of C2 is square root of 40. So that's the radius of C2, square root of 40. So if we do 15 minus, because from that 0, 0 point to that point there is 15. So 15 minus 9.5, it gives you 5.5. So cosine of theta is adjacent, which is 5.5, over the hypotenuse, which is square root of 40. So AXO, the center is X. AXO is that angle there I'm shading in red. Is given by, we call it theta, is 0.516. And to get AXB is to double it. So it's 2 times that. So AXO is a small angle theta. AXB is the complete angle, which you double it, and that will give you 1.03 radians. To find C2, the radian for C2, the arc for C2, you would use S is equals to arrow theta. R is square root of 40, and the angle is 2 pi minus 1.03. That will give you 33.207. So to get the perimeter, you want to add the distance, the arc for the big circle and the arc for the small circle. So 56.48 plus 33.207. That gives you 89.686. And to 1 decimal place is 89.7. Question number 12. In this question, you must show all the stages of your working. Show that cosec theta minus sine theta is identical to cos theta cot theta. To do this question, we write cosec theta as 1 over sine theta. Remember the S there. The S represents the sine. That's the way to remember it, 1 over sine theta. So we can write it as 1 over sine theta minus sine theta. So cosec theta is 1 over sine theta minus sine theta. We subtract it. We can use the upside down table method. So that means you draw an upside down table. If that is a table, you draw an upside down table. You do 1 times 1 is 1. Sine theta times sine theta is sine theta squared. Sine theta times 1 is sine theta. So that's the upside down table, and that's what you get. But we know 1 minus sine squared theta is cos squared theta. We use this identity. Cos squared theta plus sine squared theta is identical to 1. Now we can split it. Cos squared theta over sine squared theta. We can write it as cos theta times cos theta over sine theta. So you have the first cos theta, and then cos theta over sine theta is cot theta, which is like 1 over tan theta, which is cot theta. And that's what you're required to show. 12b, hence or otherwise, solve for 0 less than x less than 180 cosec x minus sin x equals to cos x cot 3x minus 50 degrees. To solve it, we have to replace cosec x sin x with cos x cot x. So instead of cosec x sin x, we remove that and replace it with cos x cot x, which we got from part A. So now we have cos x cot x is equals to cosec x cot 3x minus 50. This is now what we want to solve. If you notice, there's cos x on the left and there's cos x on the right. So that's common. So we factorize out cos x. So cos x on the left, cos x on the right, it comes out. We are left with cot x, and we're left with cot 3x minus 50. So either cosec x is equals to 0, which you write it there, and that means x is inverse cosine of 0 is 90 degrees, or cot x minus cot 3x minus 50 is equals to 0. If we take cot 3x minus 350 to the right side, it becomes plus. So it's cot x equals to plus cot 3x minus 50. Now you notice that you have cot x on the left, cot on the right. So we can remove the cot. That means 3x is equals to 3x minus 50. So if you take x to the right hand side, it becomes 3x minus x. And take the minus 50 to the other side, it becomes 3x minus x equals to 50. 3x minus x is 2x. So 2x equals to 50, and x is 25. Now, tan x has a period of 180 degrees. It repeats every 180 degrees. So cot x would have a period of 180 degrees. So if we can rearrange this to look like that. 2x minus 50, put the 50 on that side. 2x minus 50 is equal to 0. And because it repeats every 180 degrees, 2x minus 50 equals to 180. So x would be 180 plus 50 over 2. It gives you 115 degrees. So these are the answers you have. Cos x is equal to 0. That means x is 90 degrees. Because the one between 0 and 180. You start at 0 and 180. That's where they want the answer. And x is 25 degrees. And x is 115 degrees. So that's part A for question 12. And that is part B for question 12. Question number 13. A sequence of numbers a1, a2, a3 is defined by an plus 1 is equals to k bracket an plus 2 over an, where k is a constant. Given that the sequence is a periodic sequence of order 3, a1 is equals to 2, show that k squared plus k minus 2 is equals to 0. So for question 13a, we can start by putting n equals to 1. So it becomes a1 plus 1, which will give you a2. So that would be n is 1, so be k bracket a1 plus 2 over a1. But they tell us that a1 is 2. So we replace a1 with 2 and a1 with 2 there. So it'll be 2 plus 2 times k over 2. So it'll be 4k over 2, which will give you 2k. So a2 is 2k. Now we put in n equals to 2. So it becomes 2 plus 1 will give you 3. And k bracket a2, replace n with 2 and n with 2. So it will end up be k bracket 2k plus 2 over 2k. So 2 can factorize out of the bracket. So you end up 2 will cancel with 2 and k will cancel with k. So you end up with k plus 1. So third term is a3 is equals to k plus 1. To get the fourth term, you put n equals to 3. N is equals to 3. So you got a3 plus 1, it gives you a4. And we know A3 is K plus 1. We put there K plus 1 and K plus 1 for the denominator. So 1 plus 2, it gives you 3. So your answer is K, bracket K plus 3 over K plus 1. And that is A4. So the four terms are A1 is 2, A2 is 2K, A3 is K plus 1, A4 is K bracket K plus 3 over K plus 1. So you find four consecutive terms and set A4 equals to A1. Why? The sequence is a periodic sequence of order 3. That means after 3, 1, 2, 3, it repeats. 1, 2, 3, it repeats. 1, 2, 3, it repeats. So that means A4 is equals to A1. So A4 is K bracket K plus 3 over K plus 1 equals to 2. You want to solve it for K. Then cross multiply 2 times K plus 1. So remove the bracket K squared. K times K is K squared and K times 3 is 3K. Remove the bracket 2 times K is 2K and 2 times 1 is 2. Take plus 2K to the left and take plus 2 to the left. So you get K squared plus 3K minus 2K minus 2 equal to 0. 3K minus 2K would give you K. So you got K squared plus K minus 2 equals to 0. So QED, I proved what I set out to. What was to be shown. That's what QED means. Question 13b. For this sequence, explain why K is not equal to 1. So we know that A1 is 2, A2 is 2K, A3 is K plus 1, and we know A4. If we put K is equals to 1, A2 would be 2 times 1, which will give you 2. A3 would be 1 plus 1, which will give you 2. A4 would be 1 plus 1 plus 3 in bracket over 1 plus 1, which gives you 4 over 2, which gives you 2. So that means A2 will be 2, A3 will be 2, A4 will be 2. So when K is equals to 1, all terms are the same, 2, 2, 2, and A1 is 2. So 2, 2, 2, 2. All terms are the same. And you can conclude that the sequence does not have a period of order 3. It does not go 1, 2, 3, same, 1, 2, 3, same. So it has an order of 1. It repeats after every one number. Question 13. Find the value of the sum of arrow equals to 1 to 80 of AR. So what we want to do is we want to solve this quadratic K squared plus K minus 2 equal to 0. And we've accepted that K cannot be equals to 1. So we ignore this first answer and we want to use K equals to minus 2. So we have the n term and we put minus 2 for K. So we replace K with minus 2. So this is what the n term look like. So we know first A1, A2, A3, A4. And here we're showing you how to use the calculator to solve that quadratic. So when we use K is minus 2, 2 times minus 2 will be minus 4. And if we put minus 2 for K there, minus 2 plus 1 will be minus 1. And we put minus 2 for K in that expression for A4. That will give us A4 to be 2. So what we're saying is that A1 is 2, A2 is minus 4, A3 is minus 1. And then A4 is 2 because it starts to repeat again. So A5 will be minus 4, which will be the same like A2. And A6 will be minus 1, which will be the same like A3. And then it starts to repeat again. A7 will be 2. A8 will be minus 4. A9 will be minus 1. So you can see it is going 2 minus 4 minus 1, 2 minus 4 minus 1, and it's going from A1. We want to find the sum up to A80. We want to go up to 80. That means it going the groups of 3, but how many 3s go into 80? So 80 divided by 3 is 26. Remainder 2. So 80 divided by 3, you got 26, remainder 2, because 26 times 3 is 78. So what now we have is there's groups of 3, 26 times, and that is just 2 minus 4 minus 1. So what we want to do, we want to add those groups of 3. So 26 times those group of 3, 2 plus minus 4 plus minus 1. That's 26 times that group of 3. Now we need to find A79 and A80, because that would take us to A78. So A78 would end with minus 1. So A79, what comes after minus 1 is 2 and minus 4. Clever thinking. What comes after A78? A79, and that would be 2 and minus 4. So you will do 26 times that, 2 plus minus 4 plus minus 1 plus 2 plus minus 4. And that will give you minus 80 as the sum from arrow equals to 1 to 80. Question 14. A large spherical balloon is deflating. At time t seconds, the balloon has radius arrow centimeters and volume v centimeters cubed. The volume of the balloon is modeled as decreasing at a constant rate. Using this model, show that dr over dt is minus k over r squared, where k is a positive constant. Given that the initial radius of the balloon is 40 centimeters, after 5 seconds, the radius of the balloon is 20 centimeters. The volume of the balloon continues to decrease at a constant rate until the balloon is empty. Solve the differential equation to find a complete equation linking r and t. Find the limitation on the values of t for which the equation in part B is valid. So for question 14, we want to write as dv over dt is equals to minus c. And we know for c, for a positive constant c, so the minus means it's decreasing, it's going down. So c is a positive constant. So we can use this dv over dt is equals to dv over dr times dr over dt. What you want to notice is that you can cross out this dr over dr. The left side will be dv over dt and the right side will be dv over dt. Now v is the volume of a sphere is 4 over 3 pi radius cube. When you differentiate with respect to the radius, the 3 comes to the front, so it's 3 times 4 over 3 pi radius cube 3 minus 1. So 3 to the front, power to the front, and then you minus 1. So that gives you 4 pi r squared. That's dv over dr. Now we want to put it in dv over dt is equals to dv over dr times dr over dt. Remember this dr there is the thing that makes you can cross it out to make the left equals to the right. So dv over dt is minus c from there, and dv over dr is 4 pi r squared, and you want to find dr over dt. So what you can do is dr over dt would be c divided by 4 pi r squared, and you can write this c over 4 pi as k. So if c over 4 pi is k, it's just minus k over r squared. So you can write dr over dt is equals to minus k over r squared. Quote erat demonstratum as required to be shown. Question 14. B, solve the differential equation to find a complete equation linking R and T. So we want to solve this differential equation. dr over dt is equals to minus k over r squared. We do it by separation of variable. So we can cross multiply. So r squared times dr is equals to dt times minus k. And we put the integral sign. When you integrate r squared, you add 1 to the power and you divide by the new power. So it becomes r cubed over 3. When you differentiate minus k with respect to t, you just add a t, minus kt, plus the constant of integration. We can call it alpha. Now the condition says at times t is equal to 0, r is 40. So the initial radius is 40 at the start. That's why t is 0. So we substitute t is 0. So t is 0 in there and 40 there. We would got minus k times 0 is 0. So alpha would be 40 cubed over 3, which is 64,000 over 3. After that, we substitute t equals to 5 and r is equals to 20. So we'll have r is 20 cubed is equals to 5 times minus k plus alpha is 64,000 over 3. What you want to do is you take 20 cubed over 3 to the right hand side, it becomes minus 20 cubed over 3. When you solve that, it will give you 56,000 over 3. Now it's times 5, you take it to the right, it becomes divide by 5. And that will give k to be minus 11200 divided by 3. So that's your k. So r cubed over 3 is equals to minus kt plus alpha. We can take multiply by 3 each of them. So this will cross out, you're left with r cubed is equals to minus 3 kt plus 3 alpha. Now we substitute k. K is minus 11,200 over 3 and alpha is 6,400. So we substitute k and alpha. So k and alpha. And we simplify, the 3's will cancel, the 3's will cancel. So you end up with r cubed is minus 11,200 t plus 6,400. 64,000. Don't forget the 0 there. Forget one of the zeros. Don't forget there's a 0 there. There's a 0 there. So what you will get, you can put this in front. So r cubed is 64,000 minus 11,200 t. Question 14c. Find the limitation on the values of t for which the equation in part B is valid. Recognize that the model is only valid when r is bigger than or equal to 0 and uses it to find t. So you can make 64,000 minus 11,200 t is bigger than or equal to 0. That's when it is valid. So minus 11,200 goes to the right, it becomes plus 11,200. After that, you divide by 11,200. So 40 over 7 is bigger than or equals to t, or t is less than or equals to 40 over 7. So for times up to and including 40 over 7 seconds. Question number 15. The curve C has equation x squared tan y equals to 9. Show that dy over dx equals to minus 18x over x to the 4 plus 81. So I'm going to use the product rule, which says dy over dx is equals to u dv over dx plus v du over dx. So the first thing we do, we identify u. So we would say u to be x squared and v to be tan y. Identify u to be x squared and v to be tan y, because it's like x squared times tan y. So we'll call product rule, x squared times tan y. Now we want to find du over dx. When you differentiate x squared, it becomes 2 in front, and then you minus 1 from the power, it becomes 2x. When you differentiate dv over dx, when you differentiate tan y, you get sec squared y dy over dx. We are using the formula there at the bottom. Differential of tan kx is k sec squared kx. Now we want to put it together in the formula dy over dx. So we want to substitute v is tan y. So substitute v for tan y. And then du over dx, which is 2x, plus u, which is x squared, plus dv over dx, which is sec squared y dy over dx. So this is dv over dx, and that is sec squared y dy over dx. And then when you differentiate 9, you will get 0, because there's no x. It's like x to the power 0. So you multiply by 0. 0 times 9 will give you 0. So when you differentiate 9, you get 0. So we know x squared tan y equals to 9. If we take times x squared to the right, it becomes divided by x squared. So that means tan y is equals to 9 divided by x squared. If we square tan y, we square 9 over x squared. And 9 over x squared, 9 times 9 is 81. X squared times x squared is x to the 4. So it's x squared times x squared is x to the 4. And then 9 times 9 is 81. And we're going to use this trigonometric identity. Tan squared x plus 1 is equal to sec squared x. So we can say sec squared y is equals to 1 plus tan squared y. All we have done is change the x to a y. Now sec squared y is equals to 1 plus tan squared y, 1. But instead of tan squared, we replace tan squared with 81 over x4, because we found out that tan squared is 81 over x4. So going now to our differential, the 2x stays the same. Tan y becomes 9 over x squared. X squared stays the same. Sec squared y now becomes 1 plus 81 over x4. So sec squared y is replaced with 1 plus 81 over x4. And dy over dx stays the same. The equals to stays the same. And the 0 stays the same. The x will cancel. And 2 times 9 will give you 18. So you have 18 over x. And then if we remove the bracket, x squared times 1 will give you x squared. X squared times 81 over x4. The x squared will cancel with 2 of them down at the bottom. So you will left with 81 over x squared. And the dy over dx stays the same. The equals to 0 stays the same. So we have 18 over x is plus 18 over x. When we take it to the right side, it becomes 18 over minus 18 over x. So we would have x squared plus 81 over x squared stays the same. Dy over dx stays the same. And that is now equals to minus 18 over x. And what we do next is, because it is times here, we take everything in the bracket to the right hand side and it becomes divide. Watch this again. So everything in the bracket goes to the right, it becomes divide. So it's minus 18 over x divided by x squared over 1 plus 81 over x squared. I put the 1 underneath because it makes it easier for you to see it's a fraction. Now we want to add what is in the bracket. There are two fractions, 1, 2. We want to add them to make one fraction. So we use the upside down table method. X squared times x squared, it gives you x4. 1 times 81, it gives you 81. 1 times x squared gives you x squared. So I'm using this upside down table method. Now, we now have it as one fraction. dy over dx now is equals to minus 18 over x. We change the divide into a times, and then we flip the fraction. The bottom goes to the top and the top comes to the bottom. So it becomes x squared at the top over x4 plus 81. One of the x at the bottom would cancel with one of the x at the top. So you're left with one x at the top. So minus 18 times that one x will give you minus 18x. And then you're left with 1 times x to the 4 plus 81, which is x to the 4 plus 81. So your dy over dx is equals to minus 18x over x to the power 4 plus 81. Quod errata demonstratum, which means as required to show. Question 15b. Prove that C has a point of inflection at x equals to the fourth root of 27. So if f double dash of A is equals to 0, the point could be a local minimum, a local maximum, or a point of inflection. You will need to look at points on either side to determine its nature. So what we want to do, we want to differentiate again. So f double dash of 0, it means you differentiate it twice. And we're going to use the quotient rule. And this is the formula for the quotient rule. So we want to differentiate this a second time. So u is the one at the top, which is minus 18x. V, the denominator, is x4 plus 81. Du over dx, when you differentiate minus 18x, you just get minus 18. When you differentiate x4 plus 81, differentiate x4, it gives you 4x cubed. Differentiate 81, you get 0. Now we're going to substitute into the quotient rule formula. So d squared y over dx squared is equals to minus 18, and v is x to the 4 plus 81, because it is v du over dx, minus u is minus 18x times dv over dx, which is 4x cubed, all divided by v squared. And v is x4 plus 81 and v squared. Now what we want to do is to multiply out and remove the brackets. So minus 18 times x4, x to the power 4, it gives you minus 18x to the power 4. Minus 18 times 81, it gives you minus 1458. Minus and minus becomes a plus. So that means 18x times 4x cubed. 18 times 4 gives you 72. X times x cubed gives you x to the 4. And it's minus and minus, it will become a plus. And the denominator stays the same. X to the 4 plus 81 squared. Now the ones I've put in yellow, you combine them because they all have x to the 4. So minus 18x to the 4 plus 72x to the 4. is the same as 72 minus 18, and that gives you 54x to the 4. And you can write 1458 as 54 times 27, because 1458 divided by 54 is 27, divided by x to the 4 plus 81 squared. So now you can write the dy over the x squared. You can factorize 54. 54 is found there and is found there. So that 54 comes out of the bracket. And you're left with x4 and you're left with 27. So 54 bracket x4 minus 27 over x4 plus 81 all squared. When x is equals to the fourth root of 27, if you take this fourth root to the left-hand side, it becomes to the power 4. So you can say x to the power 4 is equals to 27. That just makes life easier when you substitute. So in that differential, we had 54, we had x4 there, so we can just substitute 27 for x to the power 4. And substitute 27 there for x to the power 4. So 27 minus 27 is 0. 0 times 54 is 0. And 0 divided by whatever is underneath here, it would be 0. So when x is equals to the fourth root of 27, you get 0. So you have shown that d squared y over dx squared is equals to 0. If you wanted, you could just substitute fourth root of 27 for x and put it to the power 4, and put fourth root of 27 for x and put it to the power 4, and put that in your calculator, you will still get 0. And you've shown that d squared y over dx squared is 0. So that could be a point of inflection. And fourth root of 27 is 2.279. Now we got to investigate to confirm, because just being equals to 0 does not mean it's a point of inflection. You need to check a number which is smaller than 27 and a number which is bigger than 27. Or looking at this, a number smaller than 2.2, like 1, a number bigger than 2.2, like 3, to see if there's a change of sign from positive to negative. So a point of inflection is a point at which f double dash of x changes sign. To find a point of inflection, you need to show that f double dash of x equals to 0, which we have done that at that point, and that it has different signs on either side of that point. And you have to watch out. A point of inflection does not have to be a stationary point. So what we're going to do is to, that's the d squared y over dx squared, and we're going to do it this way. We're going to choose a number which is smaller than fourth root of 27. The fourth root of 27 was 2.2 something. So we can choose a number smaller, we can choose 1. And we're going to choose a number which is bigger than the fourth root of 27. And we can choose 3. So 2.27, fourth root of 27 is say 2.3. So we'll try 1 and we're going to put 3. Where do we put this? We put the 1 in that d squared y over the x squared. So we put 1 there and we put 1 there. And when you put it in your calculator, you'll get minus 351 over 1681, which is a negative. Now we go and use 3. We put 3 there in place of x and put 3 there in place of x. Put that in your calculator, you get 1 over 9, which is positive. So we see that there's a change of sign, negative to positive. Now we can conclude by stating that when x is smaller than the fourth root of 27, when x is say 1, we get d squared y over the x squared is less than 0. That means it is negative. When x is equals to the fourth root of 27, we get d squared y over the x squared is 0. And when x is bigger than or greater than the fourth root of 27, we use 3 in this case. D squared y over dx squared is bigger than 0. So it's going from negative, 0, positive. So that shows that it is a point of inflection. Out of interest, another way to do it, a different method involves finding d cubed y over dx cubed. That means you differentiate the third time. And then you show that d cubed y over dx cubed is not equals to 0. And d squared y over dx squared is equal to 0 when x is the fourth root of 27. So in this case, if you differentiate the third time, d cubed y over dx cubed would be 23328x cubed over x to the 4 plus 81 all cubed, and it will give you 0.219, which is not equals to 0. 0.219 is not equal to 0, and that would show that it is a point of inflection. That's another way to do it. So that's the first part of question 15. So for 15a, you differentiate the first time. And that's the second part of 15a, which you require to show. That's question part B, question 15b. You differentiate using the quotient rule to get d squared y over dx squared. And that's the last part of question 15b, which you want to show that it is a point of inflection at fourth root of 27 when x is equals to the fourth root of 27. Question 16. Prove by contradiction that there are no positive integers p and q such that 4p squared minus q squared equals to 25. So we want to set up the contradiction and factorize. There are positive integers p and q such that 2p plus q bracket 2p minus q is equal to 25. And we are using the difference of two squares, that formula there. So 2p squared minus q squared is 2p plus q, 2p minus q equals to 25. If true, then 2p plus q is equals to 25, and 2p minus q is equals to 1, because 25 times 1 is 25. So we can solve these two equations. So we can add equation 1 and 2. 4p, 2p plus 2p is 4p. Q plus minus q is 0. 25 plus 1 is 26. So 4p is equal to 26. So p is 26 divided by 4. P is 6.5. So we can have 2p minus q is equals to 1. So 2 times 6.5, because p is 6.5. So 2 times 6.5 minus q is equals to 1. 2 times 6.5 is 13. 13 minus q equals to 1. So you take 1 to the left, 13 minus 1. Take minus q to the right, it becomes plus q. 13 minus 1 is q, so q is 12. So this is a contradiction, as there are no integer solutions. Hence, there are no positive integers p and q such that 4p squared minus q squared equals to 25.